Hey, welcome to a new video. During World War II, German U-boats posed a massive threat to Allied supply routes in the North Atlantic. To counter this, British inventor Geoffrey Pike proposed an unorthodox idea, building a gigantic aircraft carrier out of ice. Thus, Project Habakkuk was born, a secret British-Canadian war experiment. Backed by Lord Mountbatten and initially approved by Winston Churchill himself. The ship was to be made from pykrete, a composite material of ice mixed with wood pulp, which was far stronger and melted more slowly than regular ice. Incredibly, bullets barely penetrated it, and it had impressive buoyancy. The original design was over 1965 feet or 600 meters long, weighed about 2.2 million tons, and featured runways long enough to accommodate heavy bombers. The durability of pykrete impressed engineers. Legend has it that Churchill requested a demonstration, during which a bullet ricocheted and nearly injured an officer. A prototype was built on Patricia Lake in Alberta, Canada, in 1943. But challenges quickly mounted. The ship required a complex cooling system to stay frozen even in cold waters, and materials and manpower were increasingly scarce. In 1944, Project Habakkuk was officially abandoned.
Are you new to this channel? Make sure to subscribe and hit the notification bell. And before we start, also like the video.
During World War II, Japan launched a secret weapon against the United States, fugo, or fire balloons. These weren't conventional bombs, but hydrogen-filled balloons carrying incendiary and fragmentation bombs, designed to ride the jet stream across the Pacific Ocean. From late 1944 to early 1945, Japan released over 9,000 balloon bombs aimed at starting forest fires, creating panic, and diverting American attention from the Pacific Front. Each balloon measured about 33 feet or 10 meters across, made of lightweight washi paper, and equipped with ballast bags and barometric sensors to maintain altitude. They could float for up to 3 days and travel more than 5,965 miles or 9,600 kilometers, an astonishing feat for the time. Around 300 balloons reached North America, from Alaska to Mexico and as far inland as Michigan. The deadliest incident occurred on May 5, 1945, near Bly, Oregon, when Elsie Mitchell and 5 children were killed after encountering a downed balloon. This was the only deadly enemy action on U.S. soil during World War II. To prevent panic and deny Japan feedback, the U.S. government enforced a media blackout. The strategy worked. Japan believed the campaign had failed and discontinued the program in 1945. The British War Office was intrigued by the idea of deploying vehicles directly into combat zones and began experimenting with airborne transport. One of the strangest projects was the Hafner Rotabuggy, also known as the Flying Jeep, a bizarre hybrid between a Willys Jeep and an autogyro. In 1942, Austrian-British engineer Raoul Hafner designed a glider version of a military jeep that could be towed by a plane and land without a runway. A standard jeep was fitted with a massive 2-blade rotor on top, a tail fin at the rear, and stabilizing rudders. It was part of a broader set of experiments, including the Rotachute and Rotatank, aimed at aerial deployment of troops and gear. Test flights began in 1943, with the jeep towed into the air by a Whitley bomber, using the rotor to glide down like a gyrocopter. Surprisingly, the Rotabuggy flew quite well. It reached speeds of up to 105 kilometers per hour and landed smoothly thanks to its spinning blades and shock-absorbing wheels. However, the project was ultimately shelved. By 1944, better methods had emerged for transporting jeeps by aircraft, rendering the concept obsolete. As naval warfare intensified, several countries developed manned torpedoes, small submersibles piloted by divers, designed for covert sabotage missions. Italy pioneered the concept with the Maiale, officially known as the Siluro a Lenta Corsa, or slow torpedo. Nicknamed the Pig due to its awkward handling, it was a 2-man sub equipped with detachable warheads. Italian divers trained in stealth and used the Maiale to infiltrate harbors and attach explosives to enemy ships. Their most famous success came in 1941 when they disabled 2 British battleships, HMS Queen Elizabeth and Valiant in Alexandria. The British developed their own version, the Chariot, based on the Italian model, with mixed results in missions across Norway and Sicily. Germany created the Niger, a single-pilot torpedo with a glass dome. Unlike the Italian and British models, the Niger was notoriously dangerous and often considered a suicide weapon. Later versions like the Martyr and Seehund showed slight improvements, but remained unreliable. The US also developed the Sleeping Beauty, a 1-man sub for secret infiltration. Although promising in tests, it never saw combat due to its complexity and shifting wartime priorities. the United States and New Zealand collaborated on an extraordinary secret weapon, Project SEAL, better known as the tsunami bomb. Initiated in 1944, the project aimed to create artificial tsunamis capable of devastating enemy coastal cities and naval bases. The idea was to trigger massive waves using a series of timed underwater explosions. Under the direction of New Zealand physicist Dr. Thomas Leach, U.S. Navy engineers conducted tests in Wellington Harbor and off New Zealand's coast. Large quantities of explosives were detonated underwater to simulate a tsunami conditions. Some tests did generate sizable waves, but they fell far short of the desired destructive power. A truly devastating tsunami would have required vastly more powerful explosives, placed with extreme precision, a logistical nightmare during wartime. Unpredictable ocean currents and the massive scale of the operation made it impractical. Project SEAL remained classified for decades, raising modern questions about the potential of such a weapon today. One of the most bizarre and ambitious secret weapons developed by the British during World War II was the Great Panjandrum. This was a massive rocket-powered explosive cart designed to smash through Germany's concrete Atlantic Wall. The concept was born in 1942 at the British Ministry of Supply. Essentially, the Panjandrum was a huge two-wheeled wooden contraption, about 20 feet or 6 meters in diameter, lined with dozens of rocket motors around its rims. The plan was to launch it from landing craft onto beaches during amphibious assaults. It would then barrel toward enemy defenses at high speed, break through obstacles, and detonate its explosive payload to clear a path for infantry and tanks. With 28 cordite rockets on each wheel, the weapon was supposed to reach speeds of up to 62 miles per hour, or 100 kilometers per hour, an early and extremely unconventional form of land-based rocket propulsion. It carried about 1,500 pounds, or 680 kilograms of explosives, meant to destroy fortified positions. In practice, however, the Panjandrum proved nearly impossible to control. The rockets provided uneven thrust, causing it to spin out, veer off course, or even launch into the air. During test runs, it became a danger to its own crew. The project was abandoned in 1943 due to its impracticality and danger. Hobart's Funnies were specially modified tanks designed to overcome the deadly obstacles of the Atlantic Wall during the D-Day landings in June 1944. Named after Major General Percy Hobart, the visionary British tank commander who conceived them, these strange but incredibly effective machines combined inventive engineering with battlefield necessity, turning standard tanks into multi-purpose assault vehicles. The Funnies included mine-clearing tanks like the Sherman Crab, fitted with rotating chains to safely detonate mines. Other models laid down carpets over soft sand and craters to help vehicles pass. Some were flamethrower tanks to clear out bunkers and trenches. There were also bridge-laying tanks to cross anti-tank ditches quickly, as well as amphibious tanks, smoke generators, and demolition vehicles. Hobart recognized that conventional tanks would be useless against the heavily fortified beaches of Normandy. These eccentric machines were crucial to breaking German defenses and played a key role in the success of Operation Overlord. At the end of World War II and the start of the Cold War, Canada and the US jointly developed an unusual aviation project, the Avrocar VZ-9 Avrocar. This was an experimental flying saucer powered by jet engines, designed as a revolutionary VTOL vertical takeoff and landing aircraft. Born from post-war fascination with disc-shaped aircraft, the Avrocar was intended to be more agile and flexible than airplanes or helicopters. Built by Avrocar and funded by the US in the late 1940s, the craft was designed for reconnaissance or transport from makeshift locations. The Avrocar used 3 jet engines to power a central turbo-rotor, directing thrust downward for liftoff. However, test flights in the 1950s revealed extreme instability. A phenomenon called hubcapping, an uncontrollable rocking motion, made hovering difficult. The Avrocar could barely rise a few feet off the ground, and flying in a straight line proved nearly impossible. Despite several improvement attempts, the project was canceled in 1961. Still, its saucer shape and secretive nature fueled UFO speculation for years. One of the strangest secret projects of World War II was undoubtedly Project Pigeon, an ambitious plan to create a biologically guided missile controlled by pigeons. Developed in 1943 by famed psychologist B.F. Skinner, the project aimed to harness animal intelligence for precision strikes, long before electronic guidance systems were available. The idea was simple yet brilliant. Pigeons were trained to recognize enemy ships on a small screen inside the nose of a missile. When they pecked at the correct image, sensors registered the action and adjusted the weapon's course. Skinner used operant conditioning, rewarding pigeons for accurate recognition. Tests showed the birds could reliably track targets and steer the missile. Housed in a tiny cockpit with a cathode ray screen, their pecking directed the missile's control surfaces. Although the system surprisingly worked, it was never further developed. The US military ultimately chose electronic alternatives. The Soviet Union used a controversial and grim tactic. Dogs trained to carry explosives and charge enemy vehicles. The idea was straightforward but brutal. Train dogs to crawl under enemy tanks, with the payload detonating upon contact. The program began in the early 1940s using stray dogs, trained to search for food under tanks. Eventually, they were taught to target moving vehicles, specifically the undercarriage, where explosives would be most effective. The hope was to undermine Germany's armored dominance, especially in large battles like Kursk. In practice, things often went wrong. Many dogs became disoriented amid the chaos of war and returned to their own lines, with tragic consequences. German soldiers were later ordered to shoot any approaching dog on sight. Despite ethical concerns and limited success, the Soviets continued the program out of sheer wartime desperation. One of the lesser-known but striking innovations from the final phase of World War II was the so-called Zielgerät 1229, nicknamed Vampir. This was the world's first portable infrared night vision system designed for infantry use. Developed in 1944 and 1945, it allowed soldiers to see in the dark, theoretically offering a tactical advantage during nighttime operations. The system was mounted on a standard rifle of the time, along with an infrared spotlight that emitted invisible light. The operator also carried a 31 pounds or 14 kilogram backpack battery to power the system. Altogether, it turned the user into an early version of a modern night patrol soldier, equipped with technology far ahead of its time. While infrared viewing itself wasn't new, the Germans were the first to deploy it in this form on the battlefield, although its use was limited. It was mainly tested by special units on the Eastern Front, who reported advantages during night reconnaissance in forests and urban areas. Still, the system's heavy weight, limited range of around 656 feet, or 200 meters, and very late deployment meant it had little strategic impact. After the war, the discovery of this device spurred accelerated research in countries like the United States and the Soviet Union. In the early 1940s, the Soviet Union experimented with one of the most ambitious and bizarre airborne warfare concepts, gliding tanks. The idea was to equip light tanks with detachable wings and a tail section so they could be towed by an aircraft and glide into battle without the need for a landing transport plane. The most well-known model was the Antonov A-40, also called the flying tank. Designed by the legendary Soviet engineer Oleg Antonov, it consisted of a T-60 light tank fitted with large wooden biplane wings and a twin tail. The tank itself served as both fuselage and landing gear. In 1942, a test was conducted where a modified T-60 was towed by a TB-3 bomber. Due to the weight, however, it had to be released early. The tank glided briefly, made a hard landing, and was recovered, proving the concept theoretically possible but completely impractical. Poor aerodynamics, excessive weight, and underpowered engines made the project infeasible. Uranverein, or the Uranium Club, was Nazi Germany's secret attempt to develop nuclear energy and potentially a powerful weapon during World War II. The project began in April 1939, shortly after German scientists Otto Hahn and Fritz Strassmann discovered nuclear fission and initially showed promise. However, it quickly ran into problems. Unlike the well-coordinated Manhattan Project in the United States, the German nuclear program suffered from a lack of central leadership, insufficient funding, and vague military objectives. Additional delays were caused by internal rivalries and distrust of certain scientific theories, especially those associated with Einstein. One of the most fascinating remnants of this project is the so-called Haigerloch reactor, built beneath a church in the town of Haigerloch in southwest Germany. Constructed in 1944 and 1945, it consisted of uranium cubes suspended in heavy water in an attempt to initiate a controlled chain reaction. The experiment ultimately failed due to a lack of sufficient uranium and an ineffective setup. In April 1945, American troops discovered the reactor during a covert mission, dismantled the installation, and seized the materials. Later analysis revealed that the German program was still far from achieving nuclear weapons technology. As German U-boats wreaked havoc on Allied shipping lanes, the British Navy sought more effective ways to destroy submarines. Depth charges were powerful but imprecise, exploding at preset depths and often missing their targets. That's why in 1942 they developed the Hedgehog, a forward-firing anti-submarine mortar that revolutionized underwater warfare. The Hedgehog launched 24 small explosives in an oval pattern ahead of the ship while maintaining sonar contact with the target, something depth charges couldn't do. Each bomb had a contact fuse and detonated only on impact with a solid object, such as a submarine hull. This minimized wasted explosions and significantly increased hit probability. The Hedgehog was installed on escort ships like corvettes and destroyers and quickly proved its worth. Not only was it more effective, but it also had a strong psychological effect. If you heard a blast, it almost always meant a hit. In the war's final stages, German engineers under Nazi command worked on bold and experimental technologies. One such project was the Windkanone, also known as the Luftkanone. Developed under Luftwaffe engineer Johannes Schmidt, this massive air cannon was designed to disable targets using nothing but air. No bullets, no explosions, just a powerful burst of air at high speed. The goal was to build a cannon that could blow a strong air blast across a battlefield to knock people off balance and disrupt light structures or troop formations. The weapon featured a 23 feet or 7 meter long barrel mounted on a train platform, powered by air tanks capable of generating wind speeds of up to 1,148 feet or 350 meters per second. Tests conducted near Prague in 1943 measured noticeable wind pressure, but its limitations quickly became clear. The range was modest, the recoil was intense, and the whole system was large and noisy. After the war, the prototype was discovered and confiscated by Allied forces. It was ultimately decommissioned, possibly to discourage further development of similar but more powerful systems. During World War II, Britain developed the H-2S radar, the world's first airborne ground mapping radar to help bombers locate targets from the air with greater accuracy. Introduced in 1943, it enabled Royal Air Force bombers, like the Halifax and Lancaster, to see the ground through clouds and darkness. The radar emitted pulses that bounced off cities, rivers, and coastlines. These reflections were displayed on a cathode ray screen in the cockpit, providing a rudimentary but useful terrain map. Thanks to H-2S, aircraft could navigate and identify bombing targets more accurately, especially useful for nighttime raids on cities like Hamburg and Berlin. But the secret didn't last long. In February 1943, a Sterling bomber carrying the system was shot down over the Netherlands. The Germans recovered the device and soon developed the Fuji 350 Naxos, a radar detector capable of homing in on H-2S signals. This marked both a technological leap and a new vulnerability. Designed by Austrian engineer Alois Sack, the AS-6 was an experimental fighter aircraft with a circular annular wing, an unusual design intended to improve lift and agility. This flying pancake had a round wing structure surrounding a conventional fuselage and tail. The idea was that this unique shape would result in superior performance at low speeds, allowing the aircraft to make tighter turns than standard fighters. The AS-6 used a radial piston engine and was built largely from wood due to wartime shortages of metal. By the time test flights began, the Luftwaffe was already dealing with fuel shortages and a growing lack of experienced pilots, leaving little room for risky experimentation. After only a few test flights, the project was abandoned. Still, the design remains fascinating. It later inspired concepts like flying disc shapes and VTOL vertical takeoff and landing prototypes. The AS-6 stands out as a rare example of bold aeronautical innovation during a desperate time, even if it proved too impractical for mass deployment. Of all the unusual weapons developed during World War II, the Bat Bomb may have been the weirdest. Under the codename Project X-Ray, the US devised a plan to drop thousands of bats equipped with tiny napalm charges over Japanese cities. The idea came from American dentist Lytle S. Adams, who proposed in 1942 that Mexican free-tail bats could carry timed incendiary bombs. The bats would be dropped over urban areas and, following their instincts, roost in the attics and roofs of wooden buildings. Then boom, a delayed detonation would start fires. Surprisingly, the project received full military approval. Tests were conducted at a base in New Mexico, but during one trial, some bats escaped and accidentally burned down a hangar and the general's car. In 1944, the program was scrapped as attention shifted to the atomic bomb. The Mistel program was a secret aviation project by the Luftwaffe involving the development of unique composite aircraft. These aircraft were essentially giant flying bombs. The name Mistel, meaning mistletoe, a parasitic plant, symbolized the upper fighter aircraft mounted atop a modified bomber. The pilot would fly the combined aircraft toward the target, then release the unmanned lower part, which continued on its own toward the objective. The most common variant featured a Focke-Wulf FW-190, mounted on a repurposed Junkers Ju-88, whose nose had been replaced with a shaped explosive warhead. The system was intended to strike heavily fortified targets, such as shipyards, bridges, or military facilities. After releasing the weapon, the pilot would return safely to base. The program began in 1943, as Germany searched for alternative methods to attack strategic objectives. Around 250 Mistel combinations were built, but only a few achieved measurable results. Some inflicted damage on infrastructure in France, but not enough to influence the war's outcome. After the war, other countries studied the technology, but the concept was ultimately abandoned. It may sound like science fiction, but Japan was actually working on a microwave-based death ray during World War II. The secret weapon, called Kugo, aimed to disable enemy aircraft by disrupting their engines or electronics with concentrated microwave radiation. Renowned physicist Shinichiro Tominaga, who would later win a Nobel Prize, was involved in the project. The concept was that a focused microwave beam could ignite fuel, disrupt ignition systems, or disable circuitry. Tests were carried out at Nihon University in Tokyo using magnetrons, the same technology later used in microwave ovens. Reportedly, the device could kill small animals at short range, indicating some level of effectiveness. However, scaling it up proved impossible. The energy needed to affect an aircraft at distance was enormous, and energy was something Japan sorely lacked in the final years of the war. Ferngelenkte Fluorokite was a groundbreaking technological development, decades ahead of its time. Initiated in 1942, the project aimed to create a vertically launched interception missile inspired by the V-2 rocket design. At roughly 25 feet or 7.5 meters tall and weighing nearly 8,000 pounds or 3,600 kilograms, it used a liquid-fueled rocket engine capable of reaching speeds up to 1,678 miles per hour, 2,700 kilometers per hour, with a range of about 31 miles or 50 kilometers and an altitude ceiling of 31 miles or 18 kilometers. It was theoretically able to engage high-altitude targets such as heavy bombers. Unlike the ballistic V-2, the Wasserfall was remotely controlled via radar guidance and manual operation, a primitive precursor to modern precision systems. Its warhead used a proximity fuse, allowing it to disrupt targets without a direct hit. Several test flights were conducted with mixed results, but it never reached mass deployment. After the war, both the United States and the Soviet Union studied the missile's design in detail. Its propulsion and guidance concepts influenced later systems like the Nike Ajax and the SA-2. However, the Wasserfall itself was never further developed or produced. In a desperate attempt to break through heavily fortified German defenses, the United States launched Operation Aphrodite. This was a bold and deadly experiment to convert retired bombers into radio-controlled flying bombs. One of the earliest attempts at drone warfare, the technology was so primitive at the time that it was as dangerous as it was innovative. Beginning in 1944, the plan involved stripping old B-17s and B-24s down to their frames and filling them with up to 20,000 pounds or 9,000 kilograms of Torpex explosives. A two-man crew would take off, climb to about 2,000 feet, arm the explosives, and parachute out. A second aircraft would then take remote control and guide the bomber toward hardened targets like V-weapon sites, U-boat pens, and underground bunkers. But the missions were extremely risky and prone to technical failure. On August 12, 1944, Lieutenant Joseph P. Kennedy Jr., older brother of the future U.S. president, was killed when his aircraft exploded shortly after takeoff. The program was quietly canceled after multiple failures and the high human cost. The Junkers. Ju-390 was one of Nazi Germany's most ambitious aviation projects. This massive aircraft was designed to reach targets as far as the American East Coast, across the Atlantic Ocean. In the early 1940s, aircraft manufacturer Junkers developed this six-engine giant as an extended version of the Ju-290. Originally intended for maritime reconnaissance and transport, the Ju-390 became most famous for its rumored connection to the mysterious America Bomber program. With a wingspan of nearly 164 feet, or 50 meters, and a theoretical range of over 6,000 miles, or 9,700 kilometers, it could have potentially reached New York. Two prototypes were built, and at least one successfully flew in 1943. It was tested for long-range missions, aerial reconnaissance, and cargo transport. What cemented the aircraft's legendary status were post-war rumors that it had flown close to New York before returning safely to Europe. Ultimately, the project was cancelled in 1944, as wartime priorities shifted, materials became scarce, and focus turned toward defensive technologies. Both prototypes were dismantled, and further development plans were shelved for good. One of the quietest technological revolutions of World War II was the VT, Variable Time Proximity Fuse, a radar-guided detonation system developed by the US and Britain. Instead of detonating on impact or by timer, this small but groundbreaking device triggered explosives when they came close enough to their target. It worked with a miniature radar transmitter and receiver. As a projectile neared an aircraft or enemy formation, the radar signal bounced back and triggered the fuse at just the right distance for maximum destruction. First deployed by the US Navy in 1942 in the Pacific, the fuse proved devastating against Japanese kamikaze planes. Later, the technology was used in artillery shells during the Battle of the Bulge in December 1944. Shells exploded above trenches, rendering cover useless. General Patton even called it the most important new development of the war. The technology was so secret that even Allied soldiers rarely knew how it worked. Long before Japan's Shinkansen or Germany's Transrapid, German engineer Hermann Kemper proposed a train that would float above its tracks using magnetic force. In the 1930s, his concept gained serious interest under the Third Reich's broader technological ambitions, not as a military project, but as a symbol of progress and modern vision. In 1934, Kemper patented a system that used electromagnetic repulsion. By activating coils along a track with alternating current, the train could levitate and move without touching the rails. The Ministry of Aviation funded a working prototype, which was tested in rural Germany in the late 1930s. Though it didn't achieve the speeds or efficiency of today's Maglev trains, it proved that magnetic levitation was technically feasible, decades ahead of its time. Focus eventually shifted to other technologies, and Kemper's project stalled. Still, his invention remained a source of inspiration, and decades later, countries like Japan and Germany would revive and refine the concept into modern high-speed systems. The most feared torpedo of the war? That title goes to Japan's Type 93, nicknamed the Long Lance by the Allies. It used oxygen-enriched air instead of compressed air, could travel over 90 kilometers per hour, 56 miles per hour, had a range of 25 miles or 40 kilometers, and carried about 1,100 pounds or 500 kilograms explosive payload. Japanese destroyers and cruisers used it with devastating effect in battles like Savo Island and Guadalcanal. It left no trail of bubbles, making it nearly invisible until it struck. As Japan's position weakened, they developed even deadlier versions like the Kaiten, a manned suicide torpedo. In 1944, these modified Type 93s were outfitted with a cockpit and larger warhead of 2,866 pounds, or 1,300 kilograms. Pilots would steer them directly into enemy ships in kamikaze-style attacks. Launched from submarines, Kaitens occasionally succeeded in sinking ships, such as the USS Mississiniwa. The Lippisch P.13a was a visionary yet never built experimental interceptor aircraft. It was designed by German aerospace engineer Alexander Lippisch, known as the father of the delta wing concept. In 1944, Lippisch envisioned a lightweight aircraft that combined simplicity with high speed, maneuverability, and an alternative power source. He developed a ramjet engine that ran on powdered coal, intended as a solution to the shortage of conventional liquid fuels. The aircraft featured a wide, triangular delta wing with sharp angles and a swept-back profile for improved aerodynamics, stability, and high-speed performance. The cockpit was located at the front, followed by the wing structure and the combustion chamber, where crushed coal would be injected and ignited. The idea was bold and unique, a solid fuel propulsion system at a time when liquid fuels were increasingly scarce. Although the engineering challenges were significant and the technology had clear limitations, the concept was tested through scale models and wind tunnel experiments. While the project was eventually abandoned, the P-13A remains one of the most remarkable designs of its time, a testament to ingenuity during an age of extreme scarcity. In the secret halls of Bletchley Park, British codebreakers built Colossus, the world's first programmable electronic computer, a landmark in technological history. Developed between 1943 and 1944, Colossus was designed to break the complex Lorenz cipher used by the German High Command, an encryption even more sophisticated than the famous Enigma machine. Engineer Tommy Flowers proposed a radical solution, an entirely electronic system based on vacuum tubes that could analyze coded messages at lightning speed. Colossus Mark I became operational in February 1944 and played a critical role in deciphering German communications ahead of D-Day. With 2,500 vacuum tubes and a speed of 5,000 characters per second, the machine was revolutionary. But the project was so secret that after the war, the machines were dismantled, and their existence was hidden. It wasn't until the 1970s that the story of Colossus finally came to light, an unprecedented achievement kept in the shadows for decades. The America Bomber project was Nazi Germany's ambitious effort to develop a long-range bomber capable of reaching targets in the United States. The plan emerged in 1942 from the desire to challenge Allied technological dominance and symbolically strike cities like New York. The Luftwaffe invited prominent aircraft manufacturers, including Messerschmitt, Junkers, Focke-Wulf, and Horten, to submit designs for a bomber with a range of 7,456 miles or 12,000 kilometers. Notable proposals included Messerschmitt Me 264, the most advanced design, though plagued by technical flaws and engine issues. Junkers Ju 390, a 6-engine aircraft with extended range. Rumors claim it may have flown near the US East Coast, though evidence is lacking. Horten H-18, a futuristic flying wing with possible radar stealth capabilities, though it never advanced beyond concept phase. Focke-Wulf Ta 400, a large bomber similar to the American B-29, which never reached production. The project was eventually abandoned due to technical hurdles, shifting priorities, and Germany's deteriorating war position. Although no America bomber ever flew a combat mission, several of its designs later inspired breakthroughs in post-war aviation technology. Deep in occupied Manchuria lay one of the darkest secrets of World War II, Unit 731. Officially called the Epidemic Prevention and Water Purification Department, it was actually a horrifying research facility for human experimentation in biological warfare. Established in 1936 by General Shiro Ishii, Unit 731 developed lethal pathogens such as plague, cholera, anthrax, and typhoid, which were tested on live prisoners under unimaginable conditions. Chinese civilians, Soviets, Koreans, and even Allied POWs were intentionally infected and vivisected without anesthesia to study disease progression. Victims were also exposed to extreme cold, dehydration, and chemical toxins. At least 3,000 people died in the facility, and tens of thousands more suffered during field tests. In one of the most infamous incidents, Unit 731 released plague-infested fleas over Chinese cities, like Ningbo and Changde, to test mass infection as a weapon. Despite these atrocities, many leaders of Unit 731 received immunity from prosecution by the US in exchange for their so-called research. This decision remains highly controversial to this day. It wasn't until decades later that more details emerged about what truly happened in this horrific facility. Which secret technology would you want to use? Let us know in the comments. If you liked the video, give it a thumbs up. If you want to see more videos we've made, click one on the screen or take a look at the channel. Thanks for watching and see you next time.